Okay. Ladies and gents, just before we start the next session, I've just got a couple of announcements. The first one, a vehicle on the car park, a black Toyota Prius, registration DN53TYG. There's no parking permit in it, and more concerning, the car's open, I believe. And when I say open, I think it's unlocked rather than locked up. So if that's anybody's vehicle in here, beat a retreat. And one thing, have we got Stephen Ward with us? Yes. Could I just have 2 seconds of your time outside, Stephen, please?
Good morning, everyone. When anyone tells me to step outside, I usually start worrying. So, well, you may have noticed on your notes there that I'm not Mike Stacey. Unfortunately, Mike can't make it today, and he's asked me to step in to cover his role as best as I can. My name's Jez Hunter. I'm also from the University of Warwick. It really is a pleasure for me to be asked to introduce a speaker here, and the speaker I'll be introducing is Paul Chatwin. Paul is a senior consultant with the Miller Group, a large construction UK business in house building and property development. Paul's role as a chartered engineer with Miller is in the energy management consultancy service. You won't be surprised to know that. And he has a wide range of experience across the energy sector. I had a little chat with him there, and a very interesting conversation it was too. What I would say is that I even discovered that we went to the same college, although as you can tell, Paul went many years before I did. Sorry, Paul. Paul's talk today will be Part L as a stepping stone to zero carbon. So without any further ado, can I hand you over to Paul, please?
Good morning, ladies and gentlemen, and thank you to the AUE and to Keele University for giving me the opportunity to present to you today. This presentation is going to be around Part L, and I think in similar fashion to what Dan did at the start, I'm just going to do a quick quiz to see if, hands up those who've heard of Part L. Thank God for that. So everybody here has heard of Part L. Hands up those that think that they influenced the result of Part L during the design development. Less hands. And final question, hands up to those that actually believe they have a thorough understanding of Part L. A few there, so questions expected from the left later on. This almost feels like a story of my life. I was born in 1973. You'll be glad to know that I won't be giving you the story of my life today, but I will be talking about Part L. I remember growing up as a child though and having condensation and ice on the windows forming in the mornings of the winter time. And that's because the regulations in their early days were more about condensation, but it wasn't until the 1990s when really the fabric efficiencies and the U values and double glazing came into force. In fact, it was in the 1990s when I first started my career as an engineer in building services, and I would use the regulations, the U values, in order to apply heat loss calculations and size of radiators. Before I go into Part L, I'm just going to talk briefly on what the government targets are and why we do have Part L, which is all to do with the conservation of fuel and power. The government targets have already been mentioned by the Vice-Chancellor this morning, in that we are looking for an 80% reduction on carbon compared to 1990 levels by 2050. And we have legally binding carbon budgets set, and I think we're one of the first countries to make it legal through the Climate Change Act. But how are we actually doing? How are we actually achieving these carbon reductions? Well, out of the greenhouse gases, carbon is the red line on the graph, the total for the greenhouse gases being the blue line, so you can see the significance of carbon in the equation. And you can see from the left the 1990 benchmark level where we need to reduce by 80%, that we've made a slim bit of progress. Fortunately, due to the recession, we made a big improvement more recently, with a little blip, due to the cold winter that we had a couple of years ago. So if we don't have any more cold winters and we have a continued recession, we should be all right. The trajectory, and this information, by the way, is from the Committee on Climate Change. It's quite an interesting document. Basically, the Committee on Climate Change are responsible for informing the government to try to help with policy changes. What the committee was saying is really we need to be following the green dotted line in order to achieve our goals. And you can see it's quite plateau, quite fairly stable reductions initially on the green line, because we still need to get policies in force. We still need to look at research and development. There's a step change, though, in 2020 on this green line. And this isn't just put in because they thought it was appropriate. It gives us a little bit of time in order to research, develop, and technology and see what happens. But it also gives time for policies to come into force. One of the major things I believe that will influence this in 2020 is the power stations, the grid, electricity supply, and how that's going to be impacted. You may or may not be aware of things like smart grids, nuclear power station. Will that really come into force? As a little side note, I watched a video clip the other day from a website called TED, and the website was suggested to me by my uncle a couple of months ago, and I kind of went onto TED and saw a presentation by Bill Gates called Carbon Zero. I thought, oh, this might be interesting. And I watched the video clip, and it was quite interesting, and he talked about the route map to zero carbon, and one of the options being zero population, although that might not be the way we need to go. Population is going to go to about 9 million, they believe. It's currently 6.8-ish, I think. But we can look at the services that we use and looking at the energy those services use, and then look at the energy efficiency side of things. But he came out with a solution that I think they're backing, which is nuclear power, taking nuclear waste from existing power stations and burning it in this deeply buried, slow kind of log in a fashion that burns over a 60-year life and creates electricity using nuclear waste. Sounds all very good, although there's 20 years of research to go before they get a volunteer to actually build one of these, and then 20 years of development. Something else on a side note in the Committee on Climate Change was carbon capture and sequestration. Is that going to be a solution? Well, the government has funded £1 billion this year towards the research and development for carbon capture and sequestration, leading to the first trial demonstration project being up and running 2017 to 2018. So all being well, that will be part of it. But there's a bigger issue there in what do you do when you compress all this carbon into a liquid form and then shove it into the ground and walk away, hopefully. We'll see. I'm getting off my comfy kind of topic here of Part L, so I'll get back to Part L. This is the roadmap for the future, and every 3 years we'll have a step change in Part L. It's going to get steadily tougher. The focus of my presentation will be on the Zero Carbon 2019, so that applies to new buildings. I am fully aware, as we all are, that refurbishment is also equally important. Since 2010, in fact since 2006, we've had Part L mandated on us via government due to the European Performance of Buildings Directive. There's only one element of Part L which is actually mandatory, and that's the criterion 1, which is the carbon compliance calculation. The rest of it you don't need to do, but you do really, otherwise you get into trouble. But the carbon compliance is something that is legally enforced. The next set of regulations which are going to be out next year, the consultation has already been carried out, and we know that the consultation is saying it's likely to be 10% tougher. We don't know what the draft publication is, although that should be out soon, and we know that the intention is to bring it into force next April/October. The reason I've got April/October there is I believe that the mandatory part of Part L won't be enforced until October, and that will probably allow the software vendors to upgrade their software to the new rules to allow industry to test it, so that if you've got buildings that are going to fall into the 2013 category, at least you can see what the impact is going to be. But without that, it's going to be 10% tougher. On buildings, when you look at the information from the Committee on Climate Change, what they're suggesting is that the reduction on fossil fuels through the building side of things is mainly going to be influenced by the Green Deal and the CRCs. That's what they're hoping is going to be the major player on reductions. I'm going to talk now about Part L, what I call the game, because in my mind, in my experience over the past 6 years, leading teams modelling buildings for compliance as well as comfort as well as energy, it has become a game. And what you need to know is what's in the software that you are compared against. So to pass or fail, I've got a very simple equation at the top of this slide that says the input data will impact pass or fail, of course. The modeller's experience will, because some modelers are more experienced than others. Some modelers are done at a more junior level because it's a process and they're supervised by more experienced engineers. And the software. There's some software across the bottom there, which is all accredited, approved software tools. Some tools you have to use for complex buildings, some you can use for more simple buildings. But you may be surprised to know that there's about a plus or minus 14% difference in result by the choice of software. So if you're failing Part L and you want to keep the design the same, try it on another software, see if you pass. Believe me, that's happened. But most importantly, I think pass or failure will be determined by your approach. Working in the consultancy industry, there's many times when I get involved right at the start. Paul, we've got a new project. We need it to pass Part L. What do we need to know? And we haven't even got a building at feasibility stage. And I say, don't worry about Part L just yet. Make sure your design is efficient. Make sure the building's orientation is sensible, and all of the common sense stuff that architects and engineers and clients are all aware of. Put in efficient plant and put in efficient fabric standards, and consider what your renewable solutions may be. Because you pretty well know now, you don't need to carry out an assessment. You know which you prefer. Do you like biomass boilers or not? Do you like PV panels on your roof or not? Is CHP appropriate for your building? And only then, at concept stage, should you really start trialling it. Because of the way information flows and changes these days so quickly, you can spend your life trying to catch up with the design and remodel different options. But you should only model, I think, at concept stage when you've got your building back from the architect, you're happy with the layout, you will be changing it, you'll be changing it throughout the whole life. But at least you can test, kick the tyres, stick it through a Part L model, put in your efficiency and see what the result is. At detail stage, when you're going out to tender, you obviously need to make sure that it still passes and still compliant, because that's going to go to building control. And then there'll be very little change until the end of the building when you construct it. The construction process might take a year, might take a year and a half, and the software gets advanced during that time, and you may rerun it and get a totally different result than you did at design stage. That sometimes throws up some problems. With EPCs, for instance, when you've got a BREEAM target saying you must get a certain score, well, if it's going to change because the software is going to change, that will cause a problem. But BREEAM actually allows you to use the same model software version at design stage for your as-built. Fortunately, I got a slide on BIM, and BIM will save the day and make this whole process a lot easier. Is it working now? Well, as a consultant who's worked with BIM for the past 12 months, I've had 1 day's training, and I feel competent to rotate the buildings and do some of the simple stuff. The engineers, when they took the BIM model and the BIM said, I am compatible with your compliance, we threw it into the compliance software, and we had gaps in walls and roofs and not lining up. It's not quite there yet. If the building was designed in a compliant way for our software, for our Part L compliance, by the architect, then that'll be okay. So we could take the architect's BIM model and we could rework it ourselves and recreate it in BIM and then import it to the software. But you might as well create it in the software in the first place. It will get there, and the technology, the software, and the users will become more familiar with this. it's similar to what Dan was saying earlier, in that you don't really want the building complex when you import it into a very sophisticated software that's going to look at three-dimensional stuff. You don't want detail. I'm going to look at a case study now of a student accommodation building and talk you through some of the quirks and interests that this project's actually had for us. I've picked student accommodation, hopefully being quite appropriate. There's quite a lot of student accommodation blocks going up these days. And there's some simple things there of the main kind of drivers: student experience, flexibility and use. But ultimately, we want efficient use of energy. We don't want to be wasteful of energy. And there was the kind of targets of an EPC 40 and BREEAM Excellent. Funny enough, the planners said, I want BREEAM very good. The client said, I want BREEAM Excellent. But the planner said, I want you to get the mandatory credits in the EPC, so I want you to get the 40, but you can go for BREEAM very good. So, early stages in the project. Paul, how are we going to pass Part L? We've got a student accommodation block. I said, don't want to model it just yet, haven't got enough information, but just tell the architect and think about some very simple factors. Let's get back one. On that graph, there's 3 columns of numbers. The left hand is what I'm saying you should be targeting for your fabric efficiencies. These are U values for your wall, windows, and your roof. They're not really hard U values to achieve, and they're not going to be costly. The window there at 1.6 is an affordable window U value these days. You can get down to 1.4 with a double glazed product, but you probably start spending a little bit more money. I've included Passive House, the German energy efficiency standards there, so a comparison of a triple glazed window of 0.85 obviously is a lot better. But with the fabric elements, the walls and the roofs and the ground floor insulation, we're getting close to Passive House standards these days, and it doesn't add a significant cost. Obviously, there is a cost impact there. The air permeability target, i.e. the air leakage rate through the building, I've targeted here 4. Now, you are allowed to get 10, which is quite a leaky building. In fact, the computer game has 5. It compares you against a building of 5. But I know, in my role currently as a contractor, a consultancy within a contractor, that we're achieving low 3s on some schools we're building. So 4, I believe, is a realistic target. What I would say is these U values and air permeability targets does depend on your building type. If you've got a lecture building or a school or an office building, then you might relax some of these figures and you'll have no impact or very little impact on the actual result of pass or failure. It goes quite clearly that if you've got a heating-only building, then a low U value, low air permeability is a sensible solution. Similarly with the services, I will say to the services engineer, by the way, I want your boilers to be 90% seasonal efficiency, please, because I know the game has got about 85% in there. So if we start off at 90, that's okay. I know that 90% is affordable, because most manufacturers have a 90% eco boiler in their range. Fans is a tough one. The fans that goes into the computer game, the power usage on fans and pumps is very low and is quite tricky to achieve in reality. But you still want to be challenging the engineers to look to achieve those targets through their design from day one. Lighting is very important. Lighting on the older version of regs was quite easier to understand, but on the more later version of the regulations, the lighting target changes on the size of your room. The smaller the room, then the higher the target, the number increases. More open plan office, then the efficiency target reduces. So I'll do a quick assessment for a student accommodation block. I'll take a typical living space. That's going to be 80% of my accommodation. So I work out what the requirement is for a living space and tell the lighting engineers, I need you to achieve a number less than 3 watts per 100 lux. Watts per metre square per 100 lux on your efficacy for your lighting. So let's go on to architects played around with the model a bit. He spoke to the engineer. We've received a BIM model. We can't import it. We've tried, but we've used it because it gives us a great representation of what our building should look like. We create the building, compare it against the BIM model or the 3D model. Yes, it does look the same. We have built it right. Let's throw it into the machine, put in the design data. We may, at this stage now, actually have some feedback from architect or builder saying, actually, can you tweak those U values? I've got a boiler, it's not quite 90, it's 91%, is that okay? Yeah, please do. And with this particular case, we passed. We passed 2010 Part L, and we got an EPC of 40. Right, we can close the book, walk away, job's done. Well, sometimes projects don't go as well as that, and also I was a bit worried about having an EPC of 40 matching the target. There's no room of safety therefore as the design develops. So let's try and knock a few points off the EPC 40. What are we actually going to do? What we're going to look at? What you won't normally get, but what I always ask for from the modelers, is these graphs. And these graphs are my starting point. They'll tell me what my actual building's doing, and they'll tell me what my notional building is. The bar chart on the right is what you've got to achieve. You've got to make sure your bar on the left is lower than the bar on the right to pass or fail Part L. The bar is split into the regulated loads: heating, domestic hot water, auxiliary lighting. There's also a cooling, but there's no cooling for this building. Once you've got armed with that information and you're looking to spend money, because that's ultimately what it is, to improve an element of the building, then you can see where you should be focusing. Now, I already got in some good stuff in this building, which is why my heat load is so low compared to the notional building. One further thing I'll say about the notional building it does is it just creates your building, changes the glass, puts some roof lights in, and changes the services to an ultra-efficient serviced building. Lighting was quite low in our building compared to the notional building, because the notional building has got some really good lighting efficiencies. It's not to say our lighting wasn't efficient. It was very good, but it probably wasn't the excellence. I could have spent all my effort without seeing that graph saying, well, let's improve the lighting because the lighting isn't really comparing much against the notional building, and spend significant money on more expensive lighting types. Not necessarily LED, but more expensive light fittings. Spending the client's money, your money. And also you've got to change those fittings. Or we can just step back, have a look at the graph and say, actually no, I'm going to focus my effort on something that affects heating and hot water. What am I going to consider? Introducing the super boiler. I found this super boiler through speaking to various people, and it increases the efficiency from 91% to 96.4%, and I can use that in my computer. And that got an EPC reduction of 1 point, and it costs about 3 times the cost of a normal boiler. So and it's technology which we would have to query and check for tried and tested. We'd want to see this up and running in practice, because what this is a combination boiler, and it's got a flue gas chamber in the middle with 2 chambers outside of that, vessels holding water. Your hot water, your domestic hot water, is in the inner chamber, and the outer chamber around that is your heating hot water. So you can have simultaneous heating and hot water, and it's well insulated. It's a good product. It's a good efficiency, but we'd want to explore it. It's got a bit of an increased capital cost element, and it gives us very little benefit. We could use one of those. I'd never really come across gas absorption heat pumps until 12 months ago, when suddenly it's becoming more and more rare. Let's talk a little bit about this technology. It has a seasonal efficiency of 130%. All the software the game is interested in is in these numbers. So I can plug now 130% into my computer, and I get a significant saving, a fantastic saving on my EPC, as well as a reduction on my carbon. It sits outside. It's got a bit of a noise to it, and it sucks heat out of the air, and it uses ammonia, slightly deadly, but we won't worry about that. It won't leak because they're very well installed, and it's outside anyway, so if it does leak, it won't kill anybody. It'll disperse quickly. Again, a good technology, tried and tested technology. It's been around for quite a long time. And if I was operating it in reality, because when I do these calculations, I try not to forget about the real world, because it's easy to get embroiled into just chugging numbers into a computer. Another technology I considered for this project was a shower waste heat, shower water waste heat recovery device, which is now for the domestic market, and it's your soil pipe, from the dedicated soil pipe from the shower, and the cold water flow that goes to the shower mixer goes through a heat exchanger, doesn't touch the water coming out the shower, and gets preheated. Water takes a lot of energy to heat. The manufacturer quotes 40 to 50% heat recovery on these shower waste heat recoveries. it'll have a big impact, and it would have a big impact to the results. The software doesn't allow for this technology, so we would have to do a little ditty on a piece of paper and submit it to building control and get him to approve it, which they do now. Building control officers are far more open to sensible conversations around Part L compliance. Slight digression, I had a leisure centre project where we were getting an EPC 27 and failing Part L. A really, really energy efficient building and failing Part L. And it's because the software had limitations during its development. But through a sensible, practical conversation with the building control officer, we were allowed to make tweaks to the input data based on calculations to back it up to make it acceptable. For instance, a swimming pool lighting design. A swimming pool is a large area of a leisure centre project, and we're being penalised because the lighting efficiency was really, really high in the game, in the notional model. And the lighting design for a swimming pool is to point lights upwards, not on the people. And when you point lights upwards, the efficiency drops off a bit. And the building control officer let us match the notional building's lighting design, and all was good. But this gas absorption heat pump works really well in the model, and it's a lot cheaper than something like photovoltaics, which may be one of the first considered solutions for the project. Let's stick some PV in, that'll save the day. 300 metres squared was modelled here and gave a significant improvement. We don't need 8-point reduction. 300 metres squared would only cost £1 million. Let's bring it down to 37 EPC, so we'll put a third of it in. So we'll only spend £350, and we'll comply with part of the EPC requirement. We'll have a bit of bunts in. Or we could go back and put in one of the gas absorption heat pumps, which was the kind of adopted solution. I talk about real world. Those don't work very well when it's really cold outside, which is pretty obvious. So we have backup boilers. So as a designer, as a mechanical engineer designer, if I was writing the operation procedure, I'll say, run the life out of that machine all year round until the outside air drops below 5 degrees C, then put the gas boilers on and don't switch it on. And you'll have more efficiency. We've got multiple buildings on this site, so the reality will be we'll be able to compare how one performs against another. So it should be quite interesting. So that's Part L, the old kind of current, well, not so old, the current strategy that I approach buildings when I'm looking for compliance. What about the future? There are a couple of bodies. The Zero Carbon Hub, which looks at the domestics and how to get to zero carbon for domestic properties by 2016. And then you've got the government-funded TEAMS, which is the Zero Carbon Non-Domestic Buildings Report, which came out in March last year, I think, which have looked at a lot of research into the future trajectory of Part L and what it means. Ultimately, what we're interested in is cost as well as compliance. Just a quick slide on the domestic. That energy hierarchy triangle is what's planned, in that you've got a line halfway through the green part, which is a fabric of energy efficiency standards. So houses that will be built, 2013 regulations, will need to achieve a certain fabric efficiency standard. Then, combined with the boiler and the fan, they have to get to a carbon compliance standard. The future 2016 zero carbon will allow them to use something in the blue bar called allowable solutions, which is still being debated, i.e. don't spend a lot of money on site putting in PV, but spend it down the road on improving the insulation of some houses or locally. So it'll go into a pot of money, maybe the Green Investment Bank, who knows. And they did change the rules, which I think we're all fairly familiar with, in that zero carbon now means only the regulated carbon. It doesn't mean the plug-in stuff, the non-regulated stuff. There is talk about in the future changes from non-regulated to regulated in elements like door curtain heaters, which are excluded, external lighting, which is excluded, lifts are excluded. They're not part of our carbon compliance. They'll probably just make life more interesting for us. So, March 2011, the non-domestic, which applies to us, the body reviewed what are the future standards likely to be, and ultimately what we're interested in is how does it affect the look of my building and how much is it going to cost me? Is it cost prohibitive? How do we get to this zero carbon standard? They looked at fabric and form of buildings first. They looked at U values. They did lots and lots of assessments using modelling of lots of different types of buildings, and they came to the conclusion that the U values are okay. We'll leave them as they are. This is the limiting U values. They saw some benefit in increasing the U values or decreasing the U values to make more energy efficient fabric for some building types, heated only building types, but they wanted to allow flexibility in design with the designers, so they said we'll leave that. They looked at form factor. What about if we had lots of narrow plan buildings, good daylight, more energy efficiency, reduction on artificial lighting? Narrow plan's better than deep plan. Too hard. Again, the conclusion was we've looked at it and it is just too difficult to come up with a sensible calculation method which will withstand being interrogated by the industry. We want to leave it flexible. Buildings should be flexible for designers. What about daylight? We could introduce a minimum daylight efficiency. We have lots of targets these days and aspirations for natural daylight factors via good design of atriums and glazing on facades. But the conclusion there again was it's just too hard. One thing they did kind of suggest, or several things they suggested, but one of them was that the EPC standard actually gives you a better rating for a natural ventilated building, whereas the Part L doesn't give you a better pass mark for a natural ventilation building compared to an air-conditioned building, because it compares the same services type. So they might look at actually changing that to give you benefits for introducing more natural ventilation. They did say that things needed more investigation, such as thermal bridging and air permeability. Although I think the air permeability target of 3 in the future is almost being achieved these days. They also looked at surfaces. And there's something called the Energy Related Products Directive coming out across Europe, which sets out minimum efficiencies for boilers and fans and pumps and the like. So they might adopt those, or they might do something better. They have given us some target efficiencies for plant air. So, for instance, boilers at 91% seasonal efficiency might be a target in 2019. Well, we've already got that. You can almost see how the industry's kind of caught up by the time they've done the research in 2010 to 2011. It's almost outdated already. Lighting, 75 luminaire lumens per circuit watt. To put that into context, a bare T5 fluorescent lamp is about 80 these days. So you would achieve that if all our lighting was bare lamps. But unfortunately, we have to put them into fittings, and the fittings then reduces the actual light that gets thrown down onto the space. They do think that in the future, LEDs will be in the hundreds, 150 luminaire lumens per circuit watt. But it's not there yet. It will take time, but it is getting there. And again, on the cooling efficiency, 4.5 is quite a difficult target. A ground source heat pump these days might be around 3.5. An air source heat pump might be around 3.5 as well. In fact, what we're finding is ground source heat pumps come out similar to air source heat pumps. A well-designed ground source heat pump should give you 4.5. What the software did, or what the group looking into the future scenarios, is they did cost-benefit models. The cost was on the capital cost of introducing different technologies, and the benefits being on carbon and energy reductions. And they looked at low, medium, and high scenarios. So in red there's an aggregate carbon reduction against the 2006 Part L. So currently, we're sitting at 25% reduction compared to 2006. Some people think that it's actually nearer 30%, the current regulations. It's actually a lot harder than they said it would be. But they're looking to start nudging up to 33, 41 to 49 as a medium scenario in each 3-year change. When you do get to 2019 and you've got your carbon compliance benchmark at 49, to get to the other 51% is what allowable solutions will be part of, unless you can do part of it in your carbon compliance. So that's what the plan is currently, how it changes in time. remains to be seen. What I haven't included here is a whole series of colourful graphs which are in this report, which looked at different building types and different technologies. And it's really a result of all the modelling scenarios they did. For a secondary school, for instance, where the target is about 35% for 2013, the costs were in the region of £50 to £100 per square metre, dependent on your technology. Again, I think that the costing is so important to get right and is dependent on quality data. PVs were about £1,000 a square metre going back not too far, but now I quote about £350 per square metre for a large array. So they've significantly reduced. So as I mentioned, the cost-benefit models were carried out and very colourful charts were created for lots of different building types. And this is the example of the secondary school. I've tried to, because the quality wasn't that good on the document which I used, I've tried to put in and highlight some of the coloured bars. So the line goes up to the 100%, gradually gets really, really more expensive. So on the right-hand side, the top number there is about £600 per square metre. And it's incrementing about 100, so you've got 98, 198. And on the bottom, you've got a percentage improvement compared to 2006. So next year's 33, then it goes up to 40 something, and then it gets nearer to 50% mark. There you can see that we're achieving 2019 regs with a 53% improvement at a cost less than £100 per square metre, according to these models. And what we've got there is we've got boilers at 91, we've got CHP, we've got photovoltaics, we've got ground source heat pump, low air permeabilities. We'll see. So in summary, Part L is very much a numbers game. And when I apply Part L to any project, every time something changes on the project, it's like, will this make a difference? Will that make a difference? And I've learnt quite a few things over time, quirks of the software, what works and what doesn't work. But it is very much a numbers game, and I can't stress the importance of getting out the results of the first pass assessment, looking at what's important and then focusing your efforts on the major components of the regulated energy. Is it lighting? Is it heating? Is it cooling or domestic hot water? BIM will help smooth out the process and the time lag behind changes happening to the design and what the impact is on Part L. And there I've summarised, in essence, what the percentage improvements will be over time. I've finished quite early, I feel. But if there's any questions, I'm quite happy to take questions from the field. Question from the front. This is all to do with new build, what I've done in this presentation, and the cost is associated with new build. Yes. I was going to repeat the question. For the benefit of the camera, the question was on whether this cost affected new builds or applied to refurbishments as well. I think we know that refurbishment works sometimes almost cost the same as new build, if not more. Is there any other questions on Part L? Compliance? Saving the planet? Yes?
Are you involved in reviewing buildings post-construction, post-completion?
Do I get involved with buildings post-completion and post?
Comparing the actual consumption in use with...
Yeah. Comparing actual energy in use and design energy. If I'm asked a question during the design, how much energy is my building going to use? My response wouldn't be, I'm going to model the building and tell you what the model says, because the model is too good. The model is not real. The model doesn't allow for opening windows and heating still being on. It's very good for the lighting, because it looks at lighting stuff. So I'd use some of the information from the model. So if I was using an energy model, and schools is a good example, I'd go to Carbon Buzz website, where there's quite a lot of school data available on real buildings and also design information. I could look at the CIBGE 2012 Guide F benchmarks which have recently been revamped, and they are better for looking at existing. But I wouldn't model it. I have modelled buildings for energy consumption, and there's a lot of thought that needs to go into when you model those buildings. And if you can tell me exactly how you're going to occupy that building, what hours, which rooms, then we'll go some part way to modelling it. As a consultant, to answer the second part of the question, do we get involved in post-completion? Very rarely. Either the money's run out and the consultant's not being paid to look at it. But I feel with BizRia Soft Landings and with my current role, which is with a contractor where we do have an FM offering and we have funding, I was talking to a gentleman earlier, if we can be involved in the FM, part of my role now is energy management. If we can do the kind of free-tiered approach to doing the simple wins to generate money that then puts in some more costly wins on carbon reduction, that then creates more money that can be put together to a new central plant. And yes, in the future my role is going to be growing in the existing building, but consultancies tend not to be, the design team tend not to be employed for the construction or post-construction. They can be. Yeah, it would be. BizRia Soft Landings is great because part of BizRia Soft Landings is after completion, the designer comes back and looks. Yes, sir.
I'm correct in assuming that your calculations and costs were based on capital.
The question there, just for the benefit of the camera, was yes, sir.
Have you considered that perhaps you should be looking at the whole life cost of the building?
Yeah. The question is, on that graph, those calculations are they based on capital cost? And the second part of the question was, should we be considering whole life cycle costings, whole life? The paper had cost-benefit models and life cycle model data. So they've got both graphs. Now, they say in the document that the life cycle cost data shouldn't be used. It's just there for information. Don't believe it. It's just there for information. They also said that if you take the life cycle, then you get significant returns on investment. But they also say that if you look at just the capital cost, every solution is more expensive than current day, which is pretty obvious. Again, the document was full of obvious stuff. Life cycle should be considered. And when I carry out Part L assessments, I do try to consider what is most appropriate in reality, as well as what gives us gains in the software. Is PV really sensible on life cycle? I can let you know that document, the title in there, and the graphs. In fact, I've got a copy with me if you need. It's colourful. They have done a lot of studies, and it has got the life cycle costing, so it is a good reference point. Any further questions? No. Thank you.
Okay, well, thank you very much for that presentation, Paul. I think with the questions from the floor demonstrates that thank you. The talk has been very interesting and inspired lots of questions, which is a good sign. I particularly like the analogy of the game, which I feel I don't know enough about the rules to, but certainly the software that sits behind that modelling, I think really, personally, I find a bit of a black art. The information goes in, and I'm never quite sure why I end up with the answer I end up with. So perhaps that's something I need to work on myself. So I think on behalf of the committee members and general members of the AUE, I will present you with a token of our esteem. Thank you very much.
Thank you.